I'm sure I'm audible enough. And Tadena Mbani, I don't know if you are able to hear me before we can start. Thank you very much, Ntate. Colleagues, we will be discussing the memo discussion for grade 10, paper 2, physical sciences for November 2025. And then we're going to start with question number 1, that's multiple choice. Now, colleagues, up to so far in terms of multiple choice, nothing has actually changed. So 1.1, it is A for 2 marks, 1.2 C also for 2 marks, 1.3 it is C, 1.4 B, 1.5 D, 1.6 also D, 1.7 it is B, 1.8 C, 1.9 B, and 1.10 it is C. And the total for question number 1 is 20 marks. So colleagues, so far nothing has actually changed. So now we'll be moving to question number 2. Now, question number 2, the question was saying the graph below represents the heating curve of water. So we were given the graph showing us the points from -20 up to 100. There were points A, B, C, D, and E on the graph. So it was a graph of temperature in degrees Celsius against the time. Question 2.1, the question was saying define the term boiling point. And then when we look at our memo for 2.1, it says boiling point, it is the temperature of a liquid at which its vapor pressure is equals to the external or atmospheric pressure. Now, colleagues, the underlined words, they are very important, so they must be there in the learner's answers. So the temperature must be there. Vapor pressure equals to the external or atmospheric pressure must also be there. And that is going to be 2 marks for that, colleagues. So it's either 2 or 0. And then 2.2, the question was saying, write the investigative question for this experiment. Now, 2.2, the answer there, it says, what is the relationship between the boiling point and the temperature? So colleagues, both the boiling point and the temperature must be there, and the question should actually be asked there, and that is going to be 2 marks for that. And then 2.3, write down the phase represented by letter C to D. So that phase, it is actually the liquid, and that is going to be for a mark. And then 2.4, the question was saying, name the process represented by letter DE. So for 1 mark, and that process there, colleagues, it's the evaporation. And then the last question, 2.5, explain in terms of kinetic molecular theory, the answer to question 2.4. Now, as the temperature increases, there'll be more molecules gaining enough energy, and therefore the rate of evaporation will actually increase. So colleagues, for that explanation, it is going to be 2 marks. Now, this is question 2, colleagues, 2.1. It is 2 marks for the definition of boiling point. 2.2, 2 marks for writing the investigative question. And then 2.3, 1 mark for the phase represented by letter C to D, which is liquid. 2.4, 1 mark for the process represented by letter DE, and that is evaporation. And then 2.5, it's an explanation of the process for DE, and it is also going to be 2 marks. Now, colleagues, this is how we're going to work. At the end of every question, we'll give you at least the time to go through these answers, and therefore, if there's anything that you want to add, colleagues, you are allowed to actually do that, so that when the final memo is being issued out, everything has been included there. So colleagues, this was question number 2. Is there anything?
Dr. Mabina?
Yes, Ndade.
Problem is solved. I will help you from the side. From look of things, there is something from Vikas. 2.2, can you accept the relation between the temperature versus time as per graph? Or maybe
change
can we
that.
ask Vikas to clarify it?
Yes, yes.
Van der Merwe?
Good morning. Can you hear me?
Yes, yes,
Yes, we
ma'am.
can hear you, ma'am.
Right. This is Regina Bali. I just want to make a comment about that statement. It says on the y-axis, it's temperature, which is good. That's what the heating curve is about. But then it also says application of heat over time. And because it's the heating curve, I think we should specify that it is temperature and not time.
You got it, Mabina?
Can she please repeat because I couldn't hear the last
Your
part.
mic also is a bit soft. Can you maybe just switch it a bit higher? And Mr. Bowling,
yes,
also you are cutting a bit. If you can just repeat what you are saying so that at least it is clear.
okay, I'll try. All right, the question states that it is the heating curve of water. So we associate it with the temperature, which is right because it's on the y-axis. But then it also gives us on the x-axis, it says application of heat and then time. So I think it's specifically about the heat that is being added. Otherwise, if you just take time, then it is not going to make sense. Well, to me, in any case.
Oh, yes, now I can hear. Yes, that is true, ma'am. The application of heat over time, that is correct. I think in that tendency, the one which says boiling the temperature against time, it has to be application of heat over time. I think that can also be accepted.
Yeah, no, if it's a label on the graph, then we have to accept it. Yeah.
Yes.
Okay. And then also there is Ingrid Extion from 2.4. Can we accept boiling?
Yes, I think so, because DE indicates actually where it is the boiling point. So evaporation can also take place at a lower temperature. So I would rather stick with boiling point and not evaporation.
I think yes, she means boiling. As because the question was asking about the process. So the process can actually be boiling, not the boiling point. If I get
Yes,
correct.
boiling.
Yes, it's boiling.
Yeah.
Okay. Okay. No, it's okay.
So
I
are
don't
we
see
going to
any.
accept? Are we going to accept evaporation?
In terms of evaporation, yeah. Let me check. It is a process where the liquid turns into gas. So for me, in that sense, even though it's going to be lower than the boiling point, I think so. I don't know about you, Baba.
Yeah, no. Let's accept it as accept. So the boiling is a process. At that point, there was, but really, if there is boiling taking place, some of those of the water obviously will be turning into a gas, and as a gas, then it is going to be evaporation. So let's accept it, Baba. It's fine. All right.
So meaning we accept evaporation.
Yeah. So
And
the
then the
boiling
process
part.
is boiling.
Yeah.
And this
Because,
one,
you know,
it is
the problem is on the boiling, on the heating curve. we never talked of boiling, but yeah, that's some of those things that we know that the grade 10 learners how they are going to do it. Yeah.
Yes.
Okay. All right. No, it's
Okay.
fine.
All right. Is there any other thing that
In the absence of any, maybe we can continue, Baba.
Okay. All right, colleagues, now let's move to question number 3. Now, in terms of question 3.1, the question was saying the two isotopes of rubidium are Rb85 and Rb87. The percentage abundance of the two isotopes is 72.2% and 27.8% respectively. And then 3.1.1, the question was saying define the term isotope. And then when we define isotope, we say these are atoms of the same element having the same number of protons but different number of neutrons. And that is going to be 2 marks for that definition, colleagues. Now, as you can see, this is not 2 or 0. So it means we're going to look at the underlined words there. For example, atoms of the same element. So for 1 mark, you'll give a learner if the learner has written atoms of the same element. And then the second mark will be coming from saying the same number, having the same number of protons, but different number of neutrons. And that is going to be 2 marks. So this one is either 2 or 1 or 0 if the learner get everything there incorrectly. And then 3.1.2, the question was saying calculate the relative atomic mass of rubidium for 3 marks. And then to calculate that relative atomic mass, the learner has to calculate firstly the part here where the learner will take the 72.2% of rubidium 85 multiplied by that 85 plus the 27.8% of the rubidium 87 then multiplied by the 87. So colleagues, it means for both this 72.2 multiplied by 85 plus 27.8 multiplied by 87, that is going to be a mark. And then the second mark will be where the learner has divided by 100. And then from there, the last mark will be for the answer, which is 85.556. Or some learners will even write 85.56, and that is going to be also correct. So that is going to be our 3 marks, colleagues. And then question 3.2. The question was saying the SP notation of an unknown element X is given below. So the SP notation was 1s2, 2s2, 2p6, and 3s1. So for element X, write down the following. 3.2.1, the question was saying write down the number of valence electrons. And then from what we see there, there's only 1 valence electron. So therefore, the learner will get a mark for saying 1. They can just write it as 1 or whatever. But even if the electron is not there, colleagues, it is going to be fine because already the electron has actually been given there. And then 3.2.2, write down the name and the symbol. So the name of the element is sodium, and then the symbol, it is Na. So 1 mark for sodium and 1 mark for Na. And then from there, 3.2.3, write down the Avbo diagram of X plus. All right. Now for this one, colleagues, this is actually, it should be 1s here. So it's 1s here. And then here we have 2s, and then here we have 2p. So for both 1s and the 2s orbital, it is going to be a mark. And then for the 2p orbital, if it is completely filled, it is going to be a mark. And then again, colleagues, remember, if we check the question, it said the Avbo diagram of X plus. So it means this X plus should actually be shown that it has lost an electron. So therefore, it is now having 10 electrons. So if ever there are 10 electrons there, colleagues, for the last part, the learner will actually get that mark there. So that is going to be 3 marks for that Avbo diagram. So it is 1 mark for both 1s and the 2s orbitals, and then 1 mark for the 2p orbital. All orbitals must be completely filled up with opposite spins. And then from there, if you check, the number of electrons should actually be 10. So for that, colleagues, Elena will get a mark. And that is question number 3. Thanks, here.
No, continue. Before you continue, Dr. Mabina, let's go back to question 2.4 and 2.5. I'd like to call in Vikas Fanoneve. You made a comment that we have to adapt. Can you clarify it for us? Because I don't know if it is your mic that it is just making a scratching sound or what. But in essence, if we are looking at that, it's a boiling point as a process. For 2.5, I think it is just a matter of changing the rate of evaporation, maybe to rate at which the gas it is. In fact, the boiling is increasing, then it is going to be the same thing. But I didn't want to preempt what he had in mind. I see your hand is up because continue.
During boiling, the temperature does not increase.
Good morning.
Morning, sir.
Yes, thank you very much. This is Mr. Jamish from Mathering. On 2.5, if the learner says that in terms of the kinetic molecular theory, they say that because there is a phase change there, it is as a result of heat energy that is absorbed, and then it weakens the intermolecular forces resulting in phase change. Or rather, they can say that the heat energy that is used, because it was in that explanation was in one of the exemplar memos, whereby it says that the heat energy is used to weaken the intermolecular forces resulting in phase change. Or I'll just look for the other one now. Or what is another option? But is that correct for now? Can we also accept that?
Yes, yes, that is correct. Because in terms of kinetic molecular theory, I think both kinetic energy and the intermolecular forces will actually be included then. So that is going to be correct.
Okay, that's fine.
Yes.
All right. Can we take Ms. Khalo?
Good morning, colleagues. My question is on 3.1. I have learners that use the revision book, but define isotopes count, same element but different mass number. Do we take that option or not? Or we just stick to the exam guideline? Because they use the grade 10 booklet that was given to them. It's defining isotope the old way.
Okay, no, it's fine because the protons and the neutrons are actually making the mass number.
Yes.
It's fine.
We accept.
Okay. We accept, yes. Mayor Bowling?
I just wanted to make a comment about 2.5 as well. If we say I wrote here, as the temperature increases, more molecules gain enough kinetic energy, because I think specifying the type of energy is also important. And then to overcome the intermolecular forces, because kinetic energy and intermolecular forces, those are the two things specific to the molecular theory. And then the Afrikaans, I will just adapt as well, because there is then just that one thing about the evaporation rate, which I did not include there.
Okay, no, it's fine. Yeah, because already temperature is a measure of kinetic energy.
Okay.
So if we are increasing it, then it is going to be an increase in. Okay. Can we take Vikas? Your hand is up, Mr. Van der Merwe.
Just confirming that I'm audible. Can you hear me? No, we can't hear you, sir.
Okay.
You sound very far.
Can Mr. Van Merwe just maybe put it in the chat and then we'll look at it, or maybe just look at your mic. We can see your hand is up again, but we can't hear you. Katleho, Tava? Katleho?
Oh, am I audible? Good morning, colleagues.
Yes, you are.
Morning, Dada.
Sir.
Okay, thank you, sir. I was asking about 2.2. If the learner wrote the relationship between temperature and states of matter, can you accept it? 2.2.
But the state is the same, isn't it the same? The same state at that point.
Is it?
Mabina, can you come in there?
Changing.
Okay. The learner is saying the relationship between temperature and what, sir?
And states of matter.
States.
Yes. Because it's changing from solid, liquid, and to gas
Okay.
when temperature increases.
I think this one we need to look at it and that because for me it is difficult to actually measure that state of matter on the other side. So can we actually look at that and then we'll come back maybe when the memo has been amended? But I will also check it.
All right, thank you, sir.
Thank you.
Thank you. Gift November. Or should we just read it as it is in the chat? Heat energy is used to overcome the intermolecular forces. A phase change may occur from liquid to a gas. However, the average kinetic energy and the speed of the molecules remains constant. That is the explanation for 2.5, I think. So the question, I don't know, is should we accept it or I don't know, because it's just in the chat and then, so that's why I need a clarity. Mr. November, can you come in, please?
No, I was just asking the NCO if you can accept or not.
Okay, Tate Mabina.
Can you please read it for me that because I can't see the.
Okay, it says heat energy is used to overcome the intermolecular forces. A phase change may occur from liquid to a gas. However, the average kinetic energy and the speed of the molecules will remain constant.
I think something that is missing there for my side. So I can see that there's an average kinetic energy there being constant, but there's something missing there in the dates here. So I'm not sure if Eva will be able to give one or not for that, but there's something missing there.
What is it that is missing?
Remember, we need to relate also things like the intermolecular forces that are being overcome. As the average kinetic energy is constant, also there must be talking about the issue of temperature increasing there. So I don't know, Baba.
Yeah, I think he's talking to it in the sense that he said the first point, heat energy is used to overcome the intermolecular forces.
Okay.
Now, from there, he say a phase change may occur from a liquid to a gas. So, however, the average kinetic energy and the speed of molecules will remain constant because if you look at that, if it is horizontal, that means there is not the kinetic energy is constant. So that means it's a measure of speed that it is there and the kinetic energy, hence it is the same. So basically it's covering the 2 points. Though the only thing that it is not there, it is talking about the average rate that it is there for evaporation or for boiling. So that is the only thing that it is missing according to the way it is in the MEMO. So because of that thing, maybe that part, that is one that is missing, then you can give a 1 out of 2 for this one. But to me, for grade 10, really, it's saying all that it is happening there. It is just that here we are having 2 marks actually, and then when in the MEMO, it's not talking about the intermolecular forces. So on a second thought, I think let's accept that 2.5 the way it is put, because it is covering almost everything that we need for that question.
Okay.
I don't know what is the feeling of other colleagues. It is our meeting, and we standardize the MEMO. We want to mark them the same, all the learners. So what is your feeling about it? Giving it a 2 the way it is?
And
I see reaction.
I would say we give 2 marks, but looking at grade 10 level, okay. The learner knows when heat is applied, the intermolecular forces become weak because it's at grade 10 level.
Yeah, that's what I was thinking also, and I agree with Chamber also, that let's accept it, let's give it a 2. Okay. And then can we go to Menteu? But maybe it's about the clarity in the marking criteria in 3.2.3. If a learner already has 11 electrons,
All right. Remember, colleagues, we said for the first one, the learners should actually show the 1s and the 2s orbital. That is going to be 1 mark. And then the 2p orbital, if it is completely filled, 1 mark. But we also check the number of electrons. So it means in that case, if the learner has shown 11, the learner will actually get 2 out of 3, because the learner did not show that X has actually lost 1 electron there.
Okay, I think it is clear that line is still giving us sodium as an atom and not a sodium ion. So we need to penalize for not knowing that one thing. Yeah, so one we do that 1 or 2. In fact, it is 2 out of 3. Okay, thanks.
Yes, and that is
Because
2 out of 3.
currently, we are penalizing the learner's choice for having 11 electrons. Please clarify the 3 marking guidelines in the updated MEMO. Okay. How are we penalizing 2, Mr. Vigas?
Am I audible, sir?
Yes, now you are. Continue, sir.
And then the third criteria says if the ion is not shown, meaning if there's 11 electrons, that electron or that mark will also be lost. So I think we must just clarify the 3 criteria for which the marks are given. The orbitals correct, the spin correct of the electrons, and then the amount of electrons.
Okay, now we'll clarify it in the guideline, but ultimately it is going to be out of 3.
Yes, sir. Thanks.
Okay, thanks. Dr. Mabina, we can continue.
Okay, no, thank you very much, Ntate. Now, colleagues, we move to question number 4. So with question 4, 4.1, the question was saying learners wanted to classify 3 substances as either metals, non-metals, or metalloids. They investigated the electrical conductivity when the temperature changed. They recorded their first findings, their findings in the table below, study the table and answer the questions that follow. So there was a table with substance ABC with initial temperature, electrical conductivity, final temperature, and electrical conductivity again. Now, the first question, write down the following 4.1.1, the non-metal. So in this case, the non-metal rather, it is C for 1 mark. And then 4.1.2, the metalloid, give a reason for the answer. The metalloid, there, colleagues, it is B. And then reason being substance B does not conduct electricity at low temperatures, but conduct electricity at high temperatures. So that is going to be another mark for the explanation, and that is going to be 2 marks. And then from there, 4.1.3, write down the metal. So the metal there, it is actually A for 1 mark. Then question number 4.2, the graph below shows the relationship between electronegativity and the atomic number in period 2. Study the graph and answer the questions that follow. So there was a graph showing the relationship between electronegativity and atomic number. And the first question, 4.2.1, the question is saying define the term electronegativity. So in terms of definition, it says it is the measure of the tendency of an atom in a molecule to attract bonding electrons, and that is going to be for 2 marks. So this one, colleagues, it is 2 or 0. And then 4.2.2, the question was saying write down the relationship between electronegativity and the atomic number as observed from the graph. Now, from the graph, we can see that as the electronegativity increases across the period, the atomic number also increases. So colleagues here will actually remove this, and then you can put the or. You can say the electronegativity increases across the period, or the electronegativity increases as atomic number increases. And that is going to be 2 marks for that. And then 4.2.3, the question was saying, explain the relationship identified in 4.2.2 above. And then in the explanation, refer to the atomic radius and the forces of attraction between nuclear charges and electrons to explain the answer there. Now, in terms of explanation, colleagues, 4.2.3, it says that atomic radius decreases across the period, or it decreases from left to right. And then the number of protons increase across the period, and the forces of attraction will also increase across the period. So that is going to be 2 marks for that, colleagues. Now remember, for 4.2.3, the learners must actually refer to atomic radius. It is actually decreasing across the period here. That is the first mark. And then the second mark is to talk about the forces of attraction. So therefore, the forces of attraction here will increase across the periods. So that is what we actually need in 4.2.3. So colleagues, that is question number 4. I don't know if there's anything that is here.
From my side, I see there is a hand from Mesahalo.
Thank you, Ntate. Ke a botsa mo 4 point e buang ka relationship, because the question is already saying to learn us the relationship between electronegativity and atomic number. What if they just say directly proportional? Because all the variables were stated from the question. Can I award one mark or two?
Okay. Actually, colleagues, you must guard against that. This thing of directly proportional, because I don't think they will be increasing with the same rate, though they will both increase. So it is better to say they are proportional, but to say directly, it's not really correct. So let them actually talk to what it is happening. So for that one, Mekele, okay, that is maybe our fault also. Let's give it a 1, not a 2, because it is not purely correct. Is there any other colleagues? Similarly, Dr. Mabina, there is nothing. We can continue.
All right, thank you very much, Ntate Tsie. Now, colleagues, we move to question number 5. Question number 5, the question 5.1, it says hydrogen gas H2 reacts with nitrogen gas N2 to form ammonia gas, which is NH3. Now, 5.1.1, the question was saying define the term chemical bonding. Now, in terms of the definition, we say it is a mutual attraction between two atoms resulting from the simultaneous attraction between the nuclei and the outer electrons. That is going to be 2 marks there, colleagues. Now, if we check the definition, the mutual, it is inside the bracket, so therefore it is optional. But attraction between the two atoms, colleagues, it must be there. So if there's an attraction between the two atoms like here, you'll give a mark for that. And then that is resulting from the simultaneous attraction between the nuclei and the outer electrons. So we also look at the underlined phrases, attraction between the nuclei and the outer electrons. That is going to be another mark. So it means for this one, colleagues, it's actually a part marking. So a learner will get 2 or 1 or 0. So we need also to look at 5.1.1 colleagues as we mark. And then 5.1.2, write down the number of bonding pairs or bonding pair of electrons in hydrogen gas. Now in hydrogen gas, we only have one electron pair. And then 5.1.3, 1 mark for that one, colleagues here. And then 5.1.3, write down the number of bonds in nitrogen gas. So there are 3 bonds in nitrogen gas, and that is going to be a mark. And then 5.1.4, the question is saying draw the Lewis dot diagram for the ammonia gas. And this is how we draw the Lewis dot diagram for ammonia gas. In terms of criteria, we look at 4 electron pairs as shown as dots or crosses around the nitrogen atom. So therefore, these are the 4 pairs that we're talking about: 1, 2, 3, 4. And then the second mark will be for 3 hydrogens, atoms, sharing 3 electron pairs with nitrogen atom. So these are the 3 hydrogen atoms there, sharing this electron pair with the nitrogen. And that is going to be 2 marks for that, colleagues. So it's going to be 2 for drawing of the Lewis dot diagram. And then 5.2. This one says, refer to the valence electrons to explain why argon is unreactive while chlorine readily forms compounds. And that is going to be for 4 marks. Now, in terms of the explanation, colleagues, for an argon, we say argon has full outer shell of 8 electrons, or you can say argon is stable. Therefore, argon does not need to gain or share electrons, or argon is chemically inert. Then from there, we move to chlorine. Chlorine has 7 valence electrons, and it shows 1 to obtain a stable structure. But what is important here, colleagues, is to talk about chlorine has 7 valence electrons, and then chlorine will always bond to another chlorine atom to obtain a stability, whilst argon will not bond as it readily has a stable structure. Now for this second part, colleagues, of chlorine here, will always bond to another chlorine. Remember, it can be any other atom here. So this one is open here. So it means chlorine will always bond to other atoms to obtain stability. But we know that for argon, it will not bond there because argon actually has a stable structure there. So colleagues, for this one, we're going to look at 2 marks for argon and then 2 marks for chlorine, meaning we talk about argon having 8 electrons, or saying argon, it is stable. Therefore, if it is stable, it means it does not need to gain or share electrons, or argon is chemically inert. So it's 1 mark for talking about maybe these 2, and then 1 mark for actually any of those here. For chlorine, the same thing, colleagues. It has 7 valence electrons, and then chlorine will always bond to another atom to obtain stability there. So that is going to be 4 marks for these colleagues. That was question number 5. I don't know if there's any clarity-seeking questions from colleagues.
Thank you, Dr. Mabina. Colleagues should also look in the chat. I think Mr. Tunzi has made 2 valuable contributions to what was happening with question 423 and what I said about it. So that is that. I think that Tunzi, your hand is up. Can shoot on.
All right. Yeah, thank you, Dr. Mabina. For that question for 5.2, I'm wondering for that second option of argon is stable. What if the learner uses the words that the examiner gave to say argon is unreactive? Would we accept that? Because already it was in comprehension of the question. And yeah, that is basically that for 5.2. Thank you.
Thank you. That I believe because it was already given that we cannot accept it. I didn't see. Because
No, they say
for
thumbs up to that
5.2,
response.
the
And
argon
then-
is unreactive, so we already is given, so will not accept it.
Ken Tatetwint is okay with it. Can we take Mr. Makalembuli?
Madam Mabina again doesn't excuse for referring you back as a belief. In question 323, how do I mark the learner if maybe the learner omits the circles, but everything is fine there, he omits only the circles. Should I give him 2 marks, 2 out of 3, or 3 out of 3? 2, 3, 3. Let me repeat it again, Mr. Mabina. I'm saying to you for question 3.23, everything there is fine. The only problem, the learner omits the circles.
So you mean the
And how
learner
do
has
I-
omitted the blocks or the
Yes,
circles?
the block. Yes, the block or the circles. It just only wrote 2 pieces. One, everything is fine. But the only omission part is based on the circles. And how should I give him a mark there? Does the learner deserve 2 marks out of 3 or 3 out of 3?
I think that Mbule, if we check the first, even though we're going to look again at the criteria for our diagram, but the first one here, it says 10 electrons shown as arrows, but it must be in blocks or in circles. So we'll give 2 out of 3 that the Mbule. I didn't see, I don't know if that is correct or not.
No, I think if it is just, I don't miswritten in white pen, but
Yes,
really
ma'am.
there is a serious mistake about it. You cannot draw over diagrams and then deviate from what it is prescribed. I am of the tendency also of punishing for the mistake. Yeah. Out of 3 that maybe.
I didn't hear you clearly. What are you saying?
We punish for not showing the blocks or the circles.
Or the circles. Meaning,
Yes, sir.
okay,
It's 2 out of 3.
thank you. Thank you. Thank you.
Let's proceed that Mabina. I don't see anything.
Okay, I didn't see. Thank you very much. Now we move to question number 6, colleagues. With question number 6, the question there is saying study the chemical and the physical processes below and answer the questions that follow. So P was given its calcium carbonate, giving us calcium oxide and carbon dioxide written in words. And then Q, it was 2H2 plus O2, giving us 2H2O. R, burning matchstick. And then S, mixing sand and water. And then 6.1, write down the letter that represent the physical change and then give a reason for the answer. Now, colleagues, according to MEMO for 6.1, it is actually P. And then in terms of the reason, it is because no new substances are formed or because the energy changes are small in relation to chemical changes, or the mass number of atoms and molecules are conserved. So that is the answer for question 6.1. And then question 6.2, using chemical formula, write down the chemical equation for P and specify the phase for each substance. And for 6.2, colleagues, this is calcium carbonate. It is CaCO3 as a solid, giving us CaO also as a solid, and then CO2 there as a gas. And then in terms of marking criteria, we will mark for the reactants, but remember, for us to mark the reactant, the arrow must be the colleagues. So therefore, we'll only mark if the arrow is there, that is for the reactant. And then for the products, the same thing will happen, calcium oxide and carbon dioxide for both of them. If the arrow is pointing towards them, it means that is going to be a mark for those products. And then the last one is to show the phases. So for calcium carbonate and calcium oxide, both must be in solid. And then carbon dioxide there as a gas. And that is going to be a third mark for 6.2. And then from there, 6.3, the question was saying consider reaction Q. Reaction Q is the one with a 2H2 plus O2 giving us 2H2O. And then 6.3.1, show by means of calculations that the mass is conserved. So what is going to happen here, colleagues? It means the learners will calculate the total mass for the reactants, and that is going to be 2 into 1 plus 1 and then plus 2 into 16, and that will give us 36 grams per mole. And then also the total mass for the products, it is 2 into 1 plus 1 plus 16, and that is also going to give us 36 grams per mole. Now, in this case, it means in terms of marking, we'll mark where the learner has calculated the total mass for the reactant and also the total mass for the products. And then after that, the learner will actually compare the two answers. So therefore, in terms of conclusion, the learner will check that the total mass of the reactants is equal to the total mass of the products, and therefore the mass is conserved. Some learners will just write the mass is conserved. That is also going to be accepted, colleagues, because you can check here, it is 36 grams per mole, 36 grams per mole for both the total mass for reactants and the total mass of the products. So the learner will actually conclude to say the mass is conserved. The other one will even say the mass of the reactants is equal to the mass of the products, and that is also going to be the conclusion, colleagues, that is going to be accepted. So for this one, it is going to be 3. And then question 6.3.2. It says also for reaction number Q, are atoms conserved in this reaction? Explain the answer. So yes, they are conserved. The answer there is yes. And then according to the balanced equation, the number of atoms on the reactant side is equal to the number of atoms on the product side. And that is going to be 2 marks for that explanation. So it is 1 mark for saying yes, and then 2 marks for the explanation. And that is going to give us the total of 3 there. All right, and then 6.4, sugar is dissolved in water. And then 6.4.1, the question is saying, yes or no, does sugar molecules break down into smaller molecules during this reaction? And then explain the answer. Now here, colleagues, the answer is no, because the sugar molecules will remain intact, or they will remain complete, or they will remain whole, or they will be undamaged, or they will be unbroken. So for any of those reasons there, colleagues, either they will remain intact, or they'll be complete, or they will remain whole, or they'll be undamaged, or they'll be unbroken. And that is going to be 1 mark for that explanation. So it's 1 mark for saying no, and then 1 mark for the explanation, and that is going to give us 2. And then the last question, 6.4.2, it says, explain the process illustrated in question 6.4.1 using the conservation of molecules. Now, in this case, where we start, we say the sugar molecules there are conserved because dissolving does not create or destroy molecules. The molecules, they just spread or they scatter or they just distribute. So it is going to be 2 marks for that explanation there, colleagues. The sugar molecules are conserved, 1 mark, because dissolving does not create or destroy molecules. The molecules just spread or scatter or distribute. So for the second part there, it is going to be a mark, and that will give us 2 marks for question 6.4.2, and the total for that question is going to be 15. But that didn't see, I don't know if colleagues are actually aware. There's something that I got here from someone, from Dade Tunzi, actually saying for 6.1 there, because the question was saying write down the letter that represent the physical change and give a reason for the answer. And the answer that was given was actually process S there, the S. So I don't know about the colleagues. Can we check 6.1 and talk about that one? Is it going to be P or S?
Yeah, that might be. It is not only with maybe Tunsi, it is also with Berna, that in fact it is Jana who talked to that, because basically sugar and sand are not going to change in any. They'll just be like that. Physically, they're not going to change. So I think it is the most appropriate than P, because with P, there will be new substances that will be formed. So it is going to be a chemical change. So I think it does hold. So it is going to change that response and also check also the explanation that we are giving. Okay. Can I give Tunsi, because he's the one who maybe wants to talk to it, and then followed by Mr. Mbuli and then Kelly. In that order, please, colleagues.
All right. Thank you, Tatensi. I am sorted with 6.1 we have already spoken to. Actually, I was raising on a point of 6.4, unless it maybe there are colleagues who want to talk about 6.1 first. I want to talk about 6.4 in totality. Maybe I don't know if I should carry on.
I think just carry on. We'll check what other colleagues are having.
Okay. Thank you so much. And Tatensi, I feel this question 6.4 may not have a place for now, because we have, in my view, this is coming from a topic called reactions in aqueous solution. So I do not expect that it be known that well that sugar will not dissolve in water. It can only be surrounded by the water molecules without breaking. So I believe it's quite out of scope for now. And my proposal would be, colleagues, please do think about it. But I think, and us as new teachers also may not really this information. It's my view. Thank you so much.
Thanks, Dr. Tunsi. We are going to address it. Okay. Can we take the next speaker?
Then see, Mr. Vinaskisi. See, one, you've said
Dr. Mbuli, you are cutting. Can you go to maybe a place where we'll hear you clearly?
So, come again?
Yeah, now we are audible.
And then, yes, that the answer is S, and then the supporting statement stays as it is. Now, how do I mark the learner if maybe the learner actually wrote P, and then also he support the answer correctly by using that statement? Should you use negative marking there, or how do you mark it? And then is that one of 631. This is whereby we're proving the law of conservation of mass. Then in your memo there, it seems as if the units they are in grams per mole. And then the learner, if he wrote grams, only grams, not grams per mole, should we penalize him for that units or what?
All right, Ntatembule, I think 6.1, for me, I don't see negative marking there. So I think the reasoning will be independent. Just check the reason and then Ntatembule.
Okay.
Colleagues, negative marking for now is suspended. So we are not going to apply negative mark. So we mark independently for that 6.1.
Okay, can you listen? Yes. And then 6.1.
Okay, sorry. Okay.
Is it me or is it still Tatembule?
Ntate Mabina, can you come in for 6.3?
Yes, 6.3.1, Ntatembule.
yeah.
If you check, we do not mark the answers. I think what I said, we need to mark only where the learner has calculated the total mass, this process of calculating the total mass, not the answers. So it does not matter whether the learner has written grams or grams per mole. But here, if the learner has shown that this will give us 36 and how, and this will give us 36 how, that is where we are going to mark. And then the answer, the final answer there will be for the conclusion, like I said.
Okay, thank you, David. Thank you.
Thank you.
Colleagues, I'm still on that 6.3, Tate Mabina. If a learner was not able to get 36, obviously the learner will say, oh, yes, the question is guiding them to show that it's conserved, but the learner did not manage to prove that it's conserved. Then now at 6.3.2, the learner says no. Should I take it as positive marking from 6.3.1 or not?
Can you please repeat?
Mr. Sello, please switch off your mic. Thank you. Kire, the learner at 6.3.1, even though the question is saying show, the question is guiding them to say that the mass is conserved. But the learner answers 6.3.2 based on the incorrect calculations they have at 6.3.1. Is 6.3.2 depending on 6.3.1 or is a standalone question?
No, 6.3.2 is a standalone question because this one, 6.3.1 was talking about whether the mass has been conserved, but 6.3.2 is talking about the atoms. So the 6.3.2 actually does not depend on 6.3.1. So both of them, they depend on the question that has been given for reaction number Q. So both of them, 6.3.1, 6.3.2, they depend on reaction Q. So they are independent of each other.
Shapundat.
Thank you.
Thank you, Ms. Khalo. Mr. Mbuli, is that a legendary hand or it's a new hand? Mbuli? I think it's an old hand. Can you go to Tunzi?
Yeah, thank you very much. 6.2, I'm not sure whether are we expecting learners to be knowing this industrial process very well as far as the writing of the state of matter. Because I don't think it's one of the reactions on that page that says representing the chemical change. So I was making a proposal that maybe perhaps of the last mark that asks for the correct faces, I think it's unfair because they would not know it's an industrial process. So perhaps we could opt for the marking rule 6.4.2, if I'm not mistaken, where it says you give 1 mark for the reactants, 1 mark for the product, and maybe for the balancing. So that is my proposal. I don't think they may get that 1 mark.
Which question is that?
6.2, that the criteria area for 1 mark for the reactant or reactants, 2nd mark for product, and yeah, that. So the proposal maybe last mark I call that. They may not get it because Ahane, they know the process very well. It's very industrial.
We'll check into that. We'll come back to you on that one. And then, can I go to Vikas? But I note you people who are on the chat. I'll come back to you just now. I just want to finish off with this one. Vikas, can you come in?
Can you hear me, sir?
Yes, I can hear you, sir.
Sir, so we got an errata at 11:30 after the learners have written. And the Afrikaans was not balanced, the equation Q. So 6.3.1 and 6.3.2, the Afrikaans learners of the schools that did not get the errata, I'm just proposing a suggestion that we adapt the memo to cater for that unbalanced equation Q.
But the equation was there.
No, it was unbalanced in the Afrikaans paper.
Yes, but the equation was given.
The equation was given, but the question says it is balanced.
Okay, no, it's fine. I know if the statement was saying it was balanced and then it is not balanced, then it is going to be a challenge. But remember, in return also, colleagues, we do balancing, but I'm not preempting what we are going to take as a decision about this. We are not going to.
The only reason
we are not going to punish the learners for our mistake. Yeah.
Because it's not a difficult equation to balance, but the lower level learner is depending on the idea that it should be balanced if it's stated as.
Yes, that's what I'm saying. Yeah. Okay.
Can I also come in there?
Yes, you are welcome.
Yes, I was saying in Afrikaans, yes, there was a mistake and the memo will actually be adapted based on that mistake and that they see.
Yeah, we agreed on that one, I know.
Yes.
Yeah.
All right.
Because is it a follow-up or is it an alternate? Okay. Tele?
No, it's an old hand.
Lower it there. Colleagues, we have other things that are coming in from this. The first one is, can you go to 5.2, Tatemabe? If a learner wrote that argon is a noble gas, it is stable and does not have to share an electron with another electron. With another element, sorry. I think that is fine.
Yes, that is fine.
We can give a mark. In fact, the 2, it's fine, suffice. The question on Q we addressed, and the P I think we addressed. Temba Dueti, I think we is referring to 6.1. Can you show it in that Mabina, that 6.1 what we have adapted? And I think Yeah, I think that is it. And then Anne-Marie, I think we'll try our best to do that, ma'am. Yeah, the updated memo will be there. Maybe the latest it is going to be tomorrow or so, but I think we will, given this afternoon, maybe we can try. Okay. I think that's all from what I see on the chat. Dr. Mabina, we can proceed.
Thank you, Ndarensi. All right, colleagues, now we move to question number 7. Question number 7 was saying 5 grams of oxygen reacts completely with sulfur dioxide to form sulfur trioxide SO3 according to the balanced equation given below. So the equation was given 2SO2 plus O2 giving us 2SO3. Now 7.1, define 1 mole of a substance for 2 marks. And then in terms of definition, we know that 1 mole of a substance, it is an amount of substance having the same number of particles as there are atoms in 12 grams of carbon-12. For this one, colleagues, it is either 2 or 0. So that is our definition for 2 marks. And then 7.2, calculate 7.2.1, the number of moles of oxygen that reacted for 3 marks. Now, in terms of the calculation, the learners will write the formula: number of moles of oxygen is equals to mass over molar mass for a mark. And then from there, it is going to be substitution of both the mass of oxygen, which is 5 grams, and then divided by the molar mass of oxygen, which is 32 grams per mole. And that is going to be another mark for that. And then from there, the number of moles of oxygen will be 0.156 mole. Or some learners will write 0.16 mole, colleagues. That is going to be a mark. So for this one, it is going to be 3 marks. And then 7.2.2, the question was saying calculate the volume of oxygen that reacted at STP. Now for this one, colleagues, it is actually a positive marking from 7.2.1. So whatever the number of moles that the learner got here is going to be used here, colleagues. So that is going to be positive marking. So the formula N equals to V over Vm, it is a mark. And then the substitution of both the number of moles of oxygen from 7.2.1 and the Vm, there's 22.4. It is going to be a mark. And then the answer there as 3.5 cubic decimeters, it is going to be a mark. Now here, colleagues, let us make sure that we check in terms of the range, because here some learners will round off to 2 decimals and they'll get an answer which is not going to be exactly 3.5. Some learners will even use all those numbers after 6 and they'll get an answer which is not going to be exactly 3.5. So there will be a range here between 3.5 to 3.6. So that one also, colleagues, is going to be 3 marks. And then the next question, it is 7.2.3, calculate the percentage yield when the 20 grams of sulfur trioxide has been produced. Now for 7.2.3, the first thing there, colleagues, is to check the ratio between sulfur dioxide and sulfur trioxide. So if you check from the balanced equation, it is actually 1:2. I'm sorry, sulfur dioxide and oxygen. I think here colleagues will just check between its sulfur dioxide and oxygen here. So therefore it is 1 for oxygen and then is to 2 for sulfur trioxide there. And then from there, the learners will get the number of moles of sulfur trioxide as 0.31 mole. They use the same number of moles here to the equation, number of moles equals to mass over molar mass, the substitution of this number of moles, and the substitution of the 80, that is the molar mass, colleagues, there. And then from there, they'll get the mass of sulfur trioxide. Then it is the percentage yield. So in terms of percentage yield, it is going to be 1 mark for the whole substitution of the 20 that was given, divided by the theoretical yield that was calculated here, which is 24.96, also multiplied by 100. So the whole substitution here, colleagues, it is going to be a mark. And then the last mark will be for the final answer of 80.12%. And this one also, colleagues, has a range between 78.125 to 80.12%, because there's positive marking from both 7.2.1 and 7.2.2. So the total for this question, it is going to be 6 marks. So therefore, we look at the ratio between oxygen and sulfur dioxide, and then the formula of calculating the number of moles of sulfur dioxide, the substitution of the number of moles of sulfur dioxide in the equation, a mark, the substitution of the mass and the molar mass of 80, it is a mark, the substitution for actual yield, theoretical yield, and the percentage, meaning the whole substitution here, it is going to be another mark. And then for the final answer with percentage, and that is going to be a mark. So that is going to be 6 marks for that, colleagues. And that is here.
Thank you, Dr. Mabina. I don't see any hand or anything on the chat. That means with question number 7, we are covered. Let's go to question 8, Baba.
Thank you, Baba. Now, the last question, which is question number 8. 8.1 says a sample of hydrated copper 2 sulfate. It is CuSO4 and then XH2O with mass of 5 grams, is heated until all the water of crystallization is removed. The mass of anhydrous copper 2 sulfate is 3.85 grams. So the equation was actually given. Now, 8.1.1, the question was saying define water of crystallization for 2 marks. Now, in terms of the definition, it is the water that is stoichiometrically bound into a crystal. And for that definition there, colleagues, it is 2 marks. So this one will be 2 or 0. Water that is stoichiometrically bound into a crystal for 2 marks is 2 or 0. And then 8.1.2, determine the value of X in the formula CuSO4XH2O for 5 marks. Now, the first step there is to calculate or find the difference in terms of the mass of water that was lost. So it is 5 grams of the hydrated copper sulfate, and then you subtract the 3.85 of the anhydrous one. So the mass of water that has been lost, it is actually 1.15 grams. So for calculating this, colleagues, it's going to be 1 mark. And then from there, the learners had to find the number of moles of copper sulfate. So it is going to be mass over molar mass. But for taking the mass of copper sulfate divided by the molar mass of copper sulfate, which is 159.5 or 160, I think in some colleagues, they've seen 159.5, and that will give us 0.024 moles. So for calculating or for substituting the mass and the molar mass here, colleagues, it is going to be a mark. And then from there, we go to water. We calculate the number of moles of water. Colleagues.
Silo, can you mute, please?
Thank you very much, Ndade. The first one, colleagues, we are going to mark where there's a substitution of 3.85 divided by 160 or 159.5, and that will give us 0.024 moles. Then the second part where we calculate the number of moles of water, it is 1.15 divided by 18, and that will give us 0.064. And then from there, it is the ratio of X, 0.064 divided by 0.024. So it's water against copper sulfate there, that is the ratio between them, and that will give us 3. So it means the answer there, colleagues, for X, it is going to give us 3. Then the last question, 8.2, is saying a certain compound is analyzed and it was found that it contains 207 grams of lead, 28 grams of nitrogen, and 96 grams of oxygen. Determine the empirical formula of the compound for 5 marks. Now, this is what we do for lead. We have the mass as 207. We'll divide that by the molar mass of lead, which is 207 also, and that will give us 1. So it is 1 mark for calculating the number of moles there of lead. And then for nitrogen, the mass is 28, and therefore for calculating the number of moles of nitrogen, which is 28 over 14 or divided by 14, it is going to be a mark. For oxygen, we have 96 grams of mass of oxygen by dividing that by 16. So 96 divided by 16, that is going to be another mark there. Now, in terms of the ratio there we can see it is 1:2:6. So therefore our ratio there for 1, 2, and 6 colleagues, for all of them, is going to be a mark. And then the last mark will be for writing the empirical formula as PB, because it is 1 is PB N2O6, or it can also be accepted where the learner will write PB into NO3 and then 2 there. So that is going to be 5 marks for that. There's also option number 2. For option number 2, colleagues, learners can actually calculate the total mass of all the elements that are there, the PB, nitrogen, and oxygen, which is 331, and then find the percentage of lead as 62.5%, the percentage of nitrogen as 8.46%, and the percentage of oxygen as 29%. From there, the learner will have to find the number of moles of lead. So they'll take 62.5, this 1% converted to the mass, divided by 207, they'll get 0.3019. And then taking the 8.46% convert to grams, divided by 14, that is going to be another mark. Then taking 29% convert to grams, divided by 16, that is going to be another mark. So for calculating the number of moles, it is going to be a mark. And then from there, colleagues, remember, learners will divide by the smallest ratio until they get the ratio as 1, 2, and 6. So for the ratio 1:2:6, it is going to be a mark. And then the last mark will be for the empirical formula, PBN2O6, or if the learner has written PB into NO3 and then 2, that is going to be the last mark. So for that one, colleagues, it is actually 5 marks. And the total for question number 5, it was 12. And the total for the paper, it was 100. I didn't see it.
Okay, Dr. Mabina. From the charts, I don't see any hand except for maybe Tunzi, who must also address the 411. I don't know because he has raised the hand. Maybe let's give him a chance.
All right, thank you, Tatensi. I am on question 8.1.2. I am not really happy with the way that we are getting that answer of 3. The reason is because in this case, the examiner has allowed that midway of the calculations that we are rounding off, or that we should round off. But if we take all the digits, the ratio between the anhydrous and water will be 1:2.66. As such, when you try to solve that, you are going to end up with a ratio of 5:8, meaning we're going to have 5 molecules of the hydrated sample, and then in the middle there should be 8. So IMPA, when it is looking like this, they have really allowed the rounding off in the middle, and I am not sure how to go about it.
Okay.
Thank you. That one.
Can you
And then-
send that over to Ntatemo Happy, and then we'll discuss it, and then we will advise.
All right, in that, we'll do. And then for 4.11, Mr. Maide will come for it maybe when you give him a chance, or unless if you give him a chance now.
I'm giving you a chance now.
Okay, Dumelang Ntate. With regard to question 4.1.1, for substance A, it says that under high and low temperature, it can conduct an electricity, and we only identify substance C as a non-metal. But then we have a case of graphite, which is a non-metal, which does conduct electricity both under low and high temperature. So I'm saying that option A should also be considered, or rather substance A should also be considered as an option for question 4.1.1.
Okay, Ntate. Point taken, Ntate Mabina.
Yes, in that the point has been taken. We'll look at that.
Okay.
Yes.
Circuit 6, I see it is Vickers. Vickers?
So I'm not sure if there's another Vickers, but mine was not up.
Is it? There is one at Circuit 6, and I don't know which circuit is that in which district. That's another problem. Circuit 6. There is VM in there. And it is written Vickers van den Merwe. But anyway, it's okay. There is no Rakina. Do you have anything to say?
No, I think it is
Okay.
fine. I think we can just leave it like that. Thank you.
All right. Colleagues, we will look into all these inputs that you have made, and we want also to thank you for making this marking guideline as standard as it is possible. We have consulted already with regards to Africans. I think we'll give a direction to that, and also for question 6.4, we'll give it. I think before the end of today, we'll have a finalized memo. We'll look into all these possibilities, and we'll let you just know. And let me also thank Ntate Mabina for the way he has conducted the memo discussion, and you colleagues, my other colleagues from the other part that we are coming from, the people who come up with this question paper, and colleagues, we appreciate what we come up with, and it is a tool that we can use going forward, especially for grade 11 and grade 12, if we are looking at what we are having at this paper. And colleagues, don't forget to also fill in the register. It is in the link. And we want to wish you a Merry Christmas and a blessed 2026. We'll be starting with our startups, and then please, colleagues, let's adhere to those, because that is the most important meeting that we'll be having, that will be mapping the way forward. And if there are changes that we have maybe seen coming and we have to implement, it is in such a meeting that we are giving you the matching orders. So please, colleagues, let's try. And I don't want to preempt what maybe Nkosinati would like to say. But Nambani, can I hand over to you?